I'm going to talk about biomimicry, which I believe is going to be an extremely useful source of ideas and innovation that will help us address some of the really key challenges of the future: climate change, resource loss, biodiversity loss, etc. And I'm also going to be talking about why I think the blockchain can help facilitate this kind of innovation. Now, before I go too much further, I think it's worth saying that I'm in no way an expert on the blockchain, and as an architect you don't necessarily have to know about everything, you just need to know when to collaborate with the right people. So this project is a collaboration at its core between four main parties. There's Better, which is a real estate company based in Switzerland. There's Exploration, which is my company. We're biomimicry architects. There's Ganica. They are global communications consultants. And then there's Robin Hood, which I guess many of you are familiar with. They describe themselves as an activist hedge fund. So this interest in biomimicry started for me very much when I was working on the Eden project. And for those of you who don't know, this is a very large botanical visitor attraction down in the southwest of England. I believe it's still the largest greenhouse in the world. And it was working on this project that really made me learn a lot about innovation in the building industry and how to take a wild idea from the computer, say, all the way through to completed building. And it was examples from biology that helped us all the way through the process, from the design of the structure, looking at examples like pollen grains and marine microorganisms, all the way through to the design of the envelope and the junctions of the steel. We learned from a whole array of different biological organisms. And I'll give a couple more examples of biomimicry. This is quite an impressive one, which I think conveys the gap between conventional human technology and the kind of sophistication of biological adaptations. So this is the bombardier beetle, and it defends itself against predators by firing a high-temperature explosion out of its abdomen. It has a combustion chamber, and it mixes together two high explosives, hydroquinone and hydrogen peroxide. And to stop the explosion migrating back to the fuel tanks, it has valves on those inlets which open and close 200 times a second. And engineers are now studying this very carefully in order to develop more efficient fuel injection systems, needle-free medical injections, and even a new form of fire extinguisher. And the closest that humans have come to this beetle so far was with the Messerschmitt 163, which used exactly the same compounds, hydroquinone and hydrogen peroxide, but they didn't have the same fuel mixing technology. So a lot of these just burst into fireballs on the ground. They weren't very popular with the pilots. But they were definitely aware of the beetle because they had these stickers on the side of the plane which said, in my bad German, wie ein Floh, aber oho, which I think translates roughly as like a beetle, but whoa. Here's another good example, one of my current favorites. This is the dog vomit slime mold, and we need more of this, and I think this would appeal to people in the blockchain world as well. The slime mold is a single-celled organism which forms minimum distance networks between sources of food. And in 2009, scientists at Hokkaido University carried out a very interesting experiment. They took a map of the Tokyo region and they put a little source of food on each of the cities surrounding Tokyo. And then they put a slime mold on Tokyo itself. What happened was that the slime mold spread out very quickly, located all those sources of food, and then it started optimizing the connections between those points. And when it had finished, that layout exactly matched the railway network layout in that part of Japan. It had taken the engineers thousands of hours to arrive at that optimization. The slime mold did it in 26 hours. It was actually a slightly better layout because it contained a few more redundant links, so it had a higher level of resilience. And I think organisms like this could be of considerable interest to people designing blockchain architecture because as an organism, it has a distributed body and it's non-hierarchical, and it forms these optimized networks. The field where biomimicry has been most intensively applied so far is in the world of robotics. It's moving on really very quickly, And yeah, as the cost of chips and bandwidth continues to reduce, I think the amount of embedded intelligence is bound to increase, and these will become more and more like living organisms. And the reason that I think biomimicry is really quite a radical source of innovation is because it should help us achieve a real step change in terms of energy efficiency, resource efficiency, and various other benefits as well. So the main project I'm going to talk about is one called the Reef, and it's to be the world's first biomimetic office. And what I'll do is I'll just explain some of the early design development, and then I'll come back to talking about why I think the blockchain is important and how that influenced the more recent path that the design has taken. So to deliver this, we had a really fantastic team of polymaths, including one of the best biomimicry professors in the world. And the way we worked was to work in a very collaborative form. The biologist helped us identify biological organisms that had solved some of the key functional challenges that we were trying to address. And I'll start with the project aim, so you've got an idea of what we were trying to achieve. We wanted to achieve a minimum of a 10% increase in productivity. We wanted the building to be, as far as possible, passively self-heating and cooling, entirely lit with daylight, for the building to be a net producer of energy, and for the air coming out to be cleaner than the air going in. And I think this picks up on another important aspect of biomimicry, which I think it should help us move beyond the sustainability paradigm to a regenerative paradigm. So sustainability all too often has been about mitigating negatives. I think it's time we move to a much more proactive paradigm that's about optimizing positives. So those last 3 bullet points there, those are actually about creating a building that is regenerative to the human spirit and to the local and broader environment. The first big functional challenge we identified was how to gather and distribute daylight into this building. And we started looking at interesting biological organisms that have evolved in interesting ways of doing this. This one is the spookfish. Now, the spookfish has these amazing mirror-shaped eyes, which are able to focus very low levels of bioluminescence coming up from the ocean and focus it onto the retina. The next one we looked at is called the stone plant. This is a plant that lives in desert regions. And for reasons of thermal stabilization, most of the plant is below the ground. And then you have what you could call a roof light at the top, which allows the light to come down to where the photosynthetic material is, and then the chemical reactions can take place at a very steady temperature. Another one we looked at is called the brittle star. Now, these are starfish that live as much as 500 meters below the ocean surface, where light levels are incredibly low, and they've evolved a covering of near optically perfect lenses over their skin, and those are able to detect very small amounts of light and movement and focus those onto receptors, so they're able to detect predators long before the predators see it. And these 3 examples, along with a lot of other biological examples of gathering light, I think encouraged us to think much more deliberately and creatively about how we would bring light into this building. A fairly conventional way of designing for light in office buildings is to just think about the right distance between the window walls. And in London, there are plenty of offices that are really deep, as much as 30 or 40 meters deep. And you know that they're going to be high energy buildings because they're artificially lit and air conditioned. And we concluded that the right distance was about 12 meters. So no one was further than 6 meters from the nearest window. And thinking about what form this suggested, one approach would be to just take these narrow floor plates and stack them up into a tower form. And that would be fine if we were working in a dense urban location with high land values. We wanted to create something that was more universal than this. So we looked at 2 other building forms. One is like a ring of office space around a central atrium. And then the third one is a more linear approach where you have these 2 linear blocks and a linear atrium down the middle. And it was the third one that seemed to work best when we analyzed the light levels. And when we looked at those in plan, with computer software that can model light levels, we found that we were getting this kind of curved pattern of shade towards the middle of each block because of the shading effect of the opposite block. So then what we did is that we simply curved those floor plates so that we get a very even quality of light all the way along. And this produced two further challenges. The first was that narrow floor plates aren't particularly good for creative clusters of people. You need some wider areas. And secondly, this wasn't making very efficient use of a rectangular site, and we were probably going to end up using a rectangular site. So then, learning further lessons from biology about surface area to volume optimization and so on, we elaborated the plan form into this undulating shape so that we were still getting no further than 6 meters from the nearest window, but now we were getting much better facilities for creative clusters of people, and we were making more efficient use of the rectangular site. Looking at the building in section and still thinking about daylight, we found that it was reasonably easy to get enough light to the upper parts of the building. The challenge was how to get the light further down. And we looked at the possibility of harvesting light from the top. And for this, we looked at a rainforest plant called Anthurium warraquinum, which, similar to the brittle star, has lenses all over its skin, which focus diffuse light. So the potential exists to focus light into fiber optic tubes and then channel that around the building to where you need it. We concluded that there was a good case for shaping the building to let in more light, and also incorporating a large-scale light reflector in the middle, a bit like the spookfish eye that would bounce light deeper into the lower parts of the building. And then thinking about what we would do underneath that large-scale mirror, we thought this was a great opportunity to create a really dramatic meeting space that would provide another asset for the building that could be let out for conferences and events. Now, turning to the way that we designed for the structure. So, with the light examples, that was we concluded that was the thing that should really drive the strategic form of the building. So, the way we used biomimicry on the structure was to try to refine the structure as much as possible. So, we'd use a minimum of materials. And in biology, there are lots of examples of really quite complex structures that achieve remarkable efficiency by putting the material in exactly the right place. So what I'm drawing here, this is a section through a bird skull where you have incredibly thin layers of bone that are connected together by struts and ties that form a complex and incredibly resource-efficient structure. The bone in a cuttlefish is pretty similar. Again, very thin layers of bone, this time connected together by these undulating walls, so forming a very stiff and very resource-efficient structure. For the office building, we analyzed a generic floor and column structure, and we analyzed this in terms of which bits of the structure were performing a lot, which ones had a lot of structural load to deal with, and which bits were structurally redundant. And all the bits I'm shading in dark here, these are the bits that are structurally redundant, the middle of the columns, the center of the slabs, and so on. So if we were to follow the shape that the building wants to be, following ideas in biology, we would end up with hollow columns. We would have slightly deeper floors in the middle where the bending moments are higher, and then we would take out the excess material with void formers. And this is only a slight departure from existing technologies like fabric formwork and bubble deck technology, and it's actually getting reasonably close to the efficiency of the biological examples that we identified. And with advances in 3D printing, moving into large-scale 3D manufacturing, there's a chance that we could get much closer to the phenomenal resource efficiency that you can see in biology. And if I had more time, I'd love to tell you how we learned from termites to design a passive heating and cooling system for the building, how we learned from folding leaf structures and folding beetle wings to design a sun shading system that lets in exactly the right amount of light and converts all surplus light into electrical energy, and also how we learnt from shells and shells and curved leaf forms to design a new glazing system, which should achieve a roughly 50% saving in glass on this building. So this is how the scheme looked after we'd done the concept study and the commercial feasibility study, demonstrating that this could be built for a reasonable budget. And you can see most of the ideas I talked about there, the form driven by daylight, the spookfish light reflector in the atrium, and maybe you can just make out the curved glazing system on the outside as well. And this is how the building would look in the atrium. So again, that's the spookfish light reflector. And I think this is radically different to conventional office buildings in terms of the quality of space, the quality of light, the way that it would foster collaboration and improve productivity. And we did some rough calculations, back of the envelope type calculations, looking at the building cost and what the value of the increase in productivity would be. So let's just say the building was going to cost 90 million Swiss francs, and there were 3,000 people working in that on a salary of 100,000 Swiss francs a year. Well, that means the salary bill is 300 million Swiss francs a year. And if you achieve a 10% increase in productivity, then that's worth 30 million Swiss francs a year, and the building would pay for itself entirely in just 3 years. So with benefits like these, you'd think that a scheme like this would be easy to implement. Well, actually, no. And the reason for that is that the construction industry on the whole is incredibly resistant to innovation. Why, you might wonder. I don't know how widely this is known outside the construction industry, but really the level of innovation in construction is diabolical. And a lot of that is to do with the fact that the financial power to deliver large-scale real estate projects is mainly in the hands of a limited number of very high net worth individuals. And there's very little pressure for them to innovate because they can make good money by just producing standard buildings which are low risk. They may use lots of energy and lots of resources and be miserable for people to work in, but the investors can make their money. So there's no real drive for them to innovate. And it's even got to the point where there's certain accepted wisdoms amongst architects that it's best not to innovate at all because you're just likely to get sued. If you are going to innovate, only innovate on one thing per building. Don't have anything on the outside of the building that moves, and all this kind of stuff, which is kind of depressingly conservative. And if anything, the industry is getting more conservative at a time when the context for which we're designing, and I'm thinking about climate change and other resource and environmental pressures, the context for which we're designing is more and more demanding of radical change. So how do we change this? Well, I definitely think that a funding approach that allows a large number of small entities to get involved could indeed change this. I think that would substantially change the attitude to innovation because it would be seen as something that's adding value rather than creating problems. And we looked at crowdfunding as a possibility. That's still a possibility, but I think the blockchain model gives much more flexibility, much easier to manage a large number of people involved, and also creating a secondary marketplace, which will be essential for the longer term development. So having identified that as the model we wanted to pursue, we then rethought the design. And what I'll talk about now is how the new finance model changed the way we developed the design of the project. We needed to rethink the scheme so that it was less aimed at a limited number of large tenants and much more designed to suit the needs of a large number of small entities and really quite a diverse number of entities as well. And we started looking at examples of ecosystems that had some of these characteristics, and coral reefs were one of the most interesting ones. Now, coral reefs are richly biodiverse. They occupy less than 1% of the world's oceans by area, and yet they support more than 50% of the ocean's biodiversity. And within coral reef ecosystems, there are a lot of very interesting relationships between organisms, a lot of symbiotic relationships in which entities have evolved to offer mutual benefits. There are quite a lot of service providers, such as the cleaner shrimp, which provides cleaning services. It rids other organisms of parasites. There are organisms that have evolved quite remarkable ways of displaying what they're about and signaling what they do. And Coral reefs are also very good at cross-fertilizing with other coral reefs in their area, and thereby increasing the genetic diversity, and even communicating with coral reefs thousands of kilometers away. So for instance, turtles often sort of take stowaway organisms that latch on and transport them to coral reefs that may be a long way away. So what we wanted to do then was to use these ideas to think of new ideas for the building, the reef building as we're calling it. We wanted to create a kind of super incubator. So the idea of incubators that promote startups, that's fairly common, but we felt that with biomimicry and with all the technical innovations, there was a chance that we could take this much further. And this is partly about creating the right culture and about communicating in the right way. And for that as well, I think the blockchain can really help us to embed the right culture with smart contracts and to maintain that. So this is an interesting example of a co-working space, Media Evolution City, where they've focused a lot on creating the right culture. So for instance, they have a reception desk, and part of the deal of the building is that everyone in the building, including CEOs, has to spend a certain amount of time at that reception desk, telling people, giving people information, finding out what's going on, and spreading news about what other organisms, if you want to call them that, in the building are doing. In that building, there's also an obligation to provide a certain amount of beer money so that you can have regular get-togethers of people that are in the building, as well as the sort of remote virtual tenants. And these are extremely effective at communicating what is going on. So for the reef, we're planning to make it an obligation for all new organisms, all new entities in the building to give a talk when they come in, so they communicate what they're about and what they offer to the biodiversity of the system, as well as regular talks about what they're doing. We're proposing to have a thinker in residence that would quite possibly come from another reef-type building somewhere else in the world that would work in this building and spread new ideas. And we would recommend having at least an annual conference that would virtually hook up with a whole chain of other similar organizations around the world, like Media Evolution City, like the Y Combinator in the US, and so on. And somewhat jokingly, we've even talked about offering a kind of detox service. So really toxic brands like Shell and BP could allow a small team of their executives to come and hang out with the hipsters for a while and learn about what it means to be a modern 21st century company. And there would also be certain rules about how big organizations are allowed to get within this building before they start to affect the biodiversity of it. And in conclusion now on the reef, what it is intended to be is an accelerator for bio-inspired businesses. We're planning to launch this officially at the blockchain conference in October in Hong Kong. And what we're very confident about is that we can use biomimicry and blockchain models to create a really great space for people to work in that is healthier, is full of natural light, it improves people's productivity, it's regenerative, improves collaboration. And I think smart contracts are going to be absolutely essential to embedding and maintaining the kind of collaborative culture that we want if the reef is to be as effective as possible. And just to finish now on one or two other very brief examples of biomimicry and what it can offer. This is a scheme that we've developed for a radical new model for a data center using far less energy than conventional models. And that sort of biological form is no accident. That is based on a very detailed understanding of the mathematical principles that you find in branching systems in biology. It's called Murray's Law. There's a very specific mathematical relationship between those branching vessels and the angles at which they branch off. And that is an evolved minimum energy solution that has allowed us to rethink the model of a data center. And then this is another one we've been working on for 7 years now. This is called the Sahara Forest Project, partly inspired by the fog-basking beetle. So this is a model for how we could create zero-carbon food in some of the most water-stressed parts of the planet, as well as creating renewable energy and revegetating deserts. And because this is based on ecosystem models of bringing together a cluster of technologies in really quite a complex, interconnected way, I think there's a very good chance that blockchain technology, blockchain models could help us resolve all those complex interactions between the different models. And finally, to draw some conclusions generally about biomimicry, I do think that it has a lot of potential to address some of the big challenges of the future. It's a very powerful source of innovation, and I think these new finance models could really help to unleash the wave of innovation that we need. And perhaps one of the mistakes of the environmental movement has been in thinking that sooner or later we will get the leadership that we need. And I think when Obama was elected, a lot of people thought, oh, finally, he's the leader we've been waiting for. And I'd like you to consider this. We are the leaders we've been waiting for. Ordinary people like you and me, determined to create and shape a better future. And the idea of shaping the future is not as strange as it might sound, because yes, you can just let the future happen to you, or you can choose to shape it. And if you choose to shape the future, then that's what you do every moment of your waking life. Moment to moment to moment, you're shaping the future. People sometimes ask me if I'm a pessimist or an optimist, and I think in many ways that's the wrong question, because both of those positions imply some sort of sense of inevitability about the future, that either you think it's going to be good or not so good. But I firmly believe that we need to decide on the future we want and then set about shaping it. Thank you very much. I'm happy to take questions if there's time.
Thank you for that fascinating talk. I just have one question. You went into a lot of detail on the biomimicry. I was just wondering exactly how you see the blockchain factoring into this. So could you go into a bit more detail about, like, what about the blockchain, or are there any parallels between, I mean, is the blockchain in any way mimicry of any biological organisms, or what made you combine the two?
Well, I think the main thing that made us combine the two is because we were really struggling to see how we could deliver the level of innovation that we knew was possible with conventional finance models, which are very resistant to innovation. So in this building, there are at least 5, possibly 10 really significant bits of innovation that will allow us to use far less energy, far less resources, and so on. And I think the chances of us delivering that through a conventional model are virtually zero. We might get just 1 or possibly 2 innovations through. And so what was appealing about the blockchain model was that if we appealed to the right sort of people and they were able to get involved because the sort of threshold of entry was within their financial realm, let's say, then we would tap into a much more receptive crowd of people in terms of innovation. And innovation would be seen as a really positive thing that contributed to the building and was consistent with their perspective on the world. So, I mean, more than that, in terms of the details of the blockchain and how it would be set up, unfortunately, I'm not the best person to answer that. I know there are 1 or 2 people from Robinhood Ventures here, so be delighted if they wanted to chip in at this point, because they know far more about it than I do.
And just a quick follow-up. Would you consider using biomimicry and applying that to financial models? I mean, is that an interesting route?
Yeah, I think it could be, and some people have started looking into this, and you know, there are some quite interesting parallels in biology. So, for instance, within an ecosystem, there are a lot of different services that are delivered, and often those have some kind of small payoff. So for instance, the pollinator that pollinates a flower often gets a little sip of nectar which nourishes them. The bird that spreads the seed gets to eat the fruit. The seed that gets deposited somewhere else is supplied with a dollop of fertilizer, which is a pretty valuable currency for what the seed wants to do, and so on. So definitely there are models. I think there are also interesting things that could be learned from the forms of ecosystems, which are very different in their characteristics to conventional human-made systems. So up until fairly recently, a lot of human-made systems, and I'm thinking more of the sort of engineering world than the digital world, a lot of human-made systems have been simple, disconnected, monofunctional, linear, wasteful, running on fossil fuels. They're extractive. They aim to maximize one goal at a time. And if you look at ecosystems, they're completely the opposite. They're complex, they're interconnected, they're distributed, diverse, they're zero waste, they're running on current solar income, they're optimized as a whole system, and they're regenerative rather than extractive. So yes, I think there could be very interesting lessons to learn there, and also in terms of the architecture of some of these systems. I think particularly fungal mycelia and slime molds offer some interesting clues.
I have a follow-up on this. It's something that since a few weeks or months I'm really interested in is looking at the analogy or how the concept of stigmergy, so the indirect coordination between ants and between organisms, can be applied by analogy to the coordination of individuals through the blockchain. What do you think about that?
Quite possibly, and yeah, I was interested to see you mention that yesterday. One of the best known examples is the pharaoh ant, which uses markers. So when they're exploring a new terrain, the sort of scout ants go off in all directions. They pursue routes, and if they find food, then they come back and mark the start of that route as positive. If they don't find it, they mark it with a different signal that says don't go down this route. And so as a kind of emergent organism, they're able to explore and map a big terrain very efficiently. And I've heard that has been used to map digital communications paths in networks. I don't know a lot about the detail of that, but definitely I think there is some interesting potential there.
So are you looking into like re-engineering of biology itself, the actual like recreation of the materials, since we're coming close to that?
That I think is distinct from biomimicry. So biomimicry is really about learning how functions are delivered in biology and then translating that understanding into solutions that suit human needs. Whereas synthetic biology is actually about creating new biological organisms. I think in time, there's a good chance that the disciplines will merge. I think synthetic biology is a fascinating new area. I think some of the sort of biohacking is a little worrying, that it's carried out with a very limited amount of control, and that means that it could well deliver some miracles and some disasters in equal measure.
Hello. Okay, this is Dan from Robin Hood. I'll try and touch on the bit where you passed over the baton. In terms of the direct application of blockchain technologies regarding biomimicry, I don't think it's exactly biomimicry means essentially you must use blockchains. It's more as an ecosystem of new ideas and new spaces, how can we reconfigure what we're using? So I've not been directly involved with this particular project. I think Axeli has, but it's been coming from the front of how do you fund these new ideas? How do new spaces open up? And I'll tell a small story, it's quite quick. So as part of Robin Hood Co-op, we raise funds for commons-based projects. Now, someone quite rightly said you can't eat a hedge fund. That's right, you can't. Equally, a lot of these projects which are trying to open up new possibilities might not happen without funding. And I think that's the space where we're engaging. Specifically the smart contracts, how you add on like meshed together functionality isn't so much what we're involved in, I don't think yet. I hope that helps.
Great, thanks very much.
Thank you.
Thank you.